Introducing the SCX Dynamic Lead Time Injector, your AI-powered solution for real-time supply chain intelligence. In today's fast-paced, complex supply chain environment, predicting accurate lead times is crucial yet challenging. The SCX Dynamic Lead Time Injector is an advanced machine learning platform that autonomously calculates and updates open purchase orders and production orders with a statistically accurate lead time while factoring in vendor performance, transportation disruptions, customs delays, seasonal congestion, production constraints, and demand patterns, while updating the master data to ensure future creation of both purchase orders and production orders to reflect the statistically calculated lead times. Unlike static ERP master data that rarely reflects reality, this interface connects directly to your historical purchase order and production order data, applying multiple machine learning models to predict what will actually happen rather than what's theoretically expected. Our intuitive interface allows procurement and production planners to analyze and inject realistic lead times by selecting multiple vendors and multiple manufacturing plants, while targeting either all available materials or a specific one. The system allows users to specify purchase dates or production dates over which to analyze historical performance patterns and calculate statistically accurate lead times. Now we'll execute a lead time calculation to see how the system transforms unreliable static data into confident, data-driven predictions that automatically updates purchase and production orders. For this example, let's choose vendors such as Advanced Optics Corp, Bright Light Technologies, and Control Tech Systems, and we will choose manufacturing plants including Atlanta plant, Austin facility, Boston plant, Chicago plant, and Denver plant. For now, we will not specify a specific material to analyze. Rather, we select all materials across the chosen vendor plant combinations and understand the historical delivery performance patterns that will inform the future lead time predictions. Now for purchase dates, we will choose to range from March 13th, 2025 to May 17th, 2025, and make production dates range from April 17th, 2025 to May 23rd, 2025. Now let's execute the lead time analysis. With our vendors and manufacturing plant selections configured and historical date ranges specified, we'll click Get Lead Time to trigger the system's machine learning algorithms. The system will now analyze thousands of historical purchase orders and production orders, comparing planned versus actual delivery performance to generate statistically accurate lead time predictions. Now you can see the system has analyzed 34 total items across our selected vendor and manufacturing plant combinations, revealing significant insights. We can see a maximum deviation of 5 days between static ERP lead times and actual delivery performance, with 14 items requiring procurement and 20 items handled through internal production. The analysis utilized 5 different machine learning models, automatically selecting the best performing model for each vendor material combination. This comprehensive approach ensures our lead time predictions are both statistically sound and practically actionable for procurement and production planning. Here the system predicts $19,200 of potential savings. The system calculates potential savings by analyzing bills of materials to identify components that must arrive together. When materials arrive at different times, some sit in inventory incurring carrying costs. The savings represent optimizing purchase order timing to align all BOM components, reducing unnecessary inventory holding costs, and improving cash flow efficiency. The detailed analysis reveals 34 items analyzed across both purchased and manufactured components, with each row showing the critical gap between static ERP assumptions and data-driven reality. The system intelligently selected the optimal machine learning model for each item: Random Forest for volatile suppliers, ARIMA for seasonal patterns, or Monte Carlo simulation for complex manufacturing processes. Take this purchase component, Power Supply D1 from Reliable Electronics, Inc. The ERP assumed a 25-day lead time, but our Random Forest model calculated 27 days based on actual delivery patterns. A 2-day deviation that seems small but prevents costly expediting and inventory shortages. Even more significant is this manufactured item, Housing Unit B2 at San Jose plant. The static routing data suggested 20 days, but Monte Carlo simulation revealed the actual production time averages 25 days, a full 5-day deviation. This discrepancy would cause downstream assembly delays and tie up component inventory unnecessarily. The system provides comprehensive drill-down capabilities. By clicking on any item, such as Power Supply D1 from Reliable Electronics Inc., you access a detailed analytics dashboard. In the dashboard, you can see a bar chart displaying the lead time analysis and the different models that were considered. The blue bars represent actual lead times, and the red bar shows lead time prediction using Monte Carlo simulation. The chart clearly visualizes how closely the Monte Carlo predictions align with real delivery performance over time. The system chose Monte Carlo simulation because it had the best correlation between the actual and calculated lead time compared to the other models. We can select an algorithm such as ARIMA and see it was less accurate for nonlinear patterns in supplier lead times. Selecting the other model, we see it was good for time series but struggled with external factors affecting lead times. The dashboard offers comprehensive insights beyond the visual chart. The model performance section shows that Monte Carlo simulation achieved exceptional accuracy with an RMSE of just 0.6 days and 93% overall accuracy. In the analysis summary, we can see the system analyzed 15 historical orders with an average lead time of 13 days and maintained an impressive average prediction error of only 0 days, with the next prediction set at 14 days. Most importantly, the future prediction section shows that based on the Monte Carlo simulation model, the predicted lead time for the next order, July 24, 2025, is 14 days, displayed in the chart above. This forward-looking prediction enables procurement planners to set realistic expectations for upcoming orders rather than relying on static ERP assumptions. Finally, with our smart filtering system, you can easily navigate through complex analysis results. Simply click Buy Only to focus exclusively on purchase components, or Make Only to analyze internal production items. The advanced filters allow you to drill down based on specific criteria, filter by order ID to track individual transactions, by material name to focus on critical components, by source, vendor, or manufacturing plant, by the machine learning model used for prediction, by deviation threshold to highlight the biggest discrepancies, or by calculated lead time ranges to identify patterns. Now you can select the items you want to update by checking the boxes next to each row, choosing to replace the static lead time with the calculated lead time based on your business judgment. After you're satisfied with your selections, simply press Update Selected to review your choices. The system presents a confirmation dialog with exactly which lead times will be changed, along with the purchase or production order that will be updated. Finally, press Confirm Update to inject these statistically accurate lead times directly into your ERP and planning modules. This seamless integration ensures your entire supply chain operates with data-driven reality instead of outdated assumptions. In summary, the SCX Dynamic LeadTime Injector transforms unreliable static lead times into intelligent, data-driven predictions, all through automated machine learning analysis that replaces weeks of manual procurement planning work. The system seamlessly integrates with your existing ERP and planning systems, automatically injecting accurate lead times to ensure your entire supply chain operates on reality, not assumptions. Choose Seeloz for supply chain intelligence that adapts to real-world conditions and delivers measurable results. The future of autonomous supply chain planning starts here. Join us in turning supply chain chaos into confidence. Visit Seeloz.com and take the first step towards precision.